Okay, so we were just talking about energy being produced through combustion. And so that means, and we were talking about fuels. And so that means that we have substances that have potential energy, and so they have a higher energy state than another substance. And when with the previous video, I had the formula for combustion up there, and I'd said in the presence of oxygen, you have this carbon-containing compound, and it has a higher energy state than the carbon dioxide that is going to be broken down into. And so that carbon dioxide has a lower energy state. And so as a result of that, heat energy is released. And we can think in terms, and this relates to potential energy, and then the release of that energy with kinetic energy is the release of that energy, and then a lower energy state. So we can look at a little picture. I always think of the Roadrunner and Coyote cartoons, a picture of a hill with a rock on top, and that rock has a higher energy state than after it has been pushed off to try and squash the Roadrunner. And invariably it would actually squash the Coyote instead, right? But anyway, so the rock has a higher energy state when it's on top of the mountain than when it has reached the bottom of the valley. And so when we talk about the fuel, we talk about the fuel has a higher energy state than what is left over after burning it, which is the carbon dioxide. So we have different energy states, and as a result of it being a lower energy state, the heat is released. Okay, so so what is heat? The definition of heat is that heat is the kinetic energy, the releasing energy that flows from a hotter object to a less hot object. Notice I didn't say a cold object. There is no such thing as cold. There's only differences in relative amounts of heat. So heat, hot and hotter, or hotter and less hot. Yeah, I know. What else do I want to say? So we have these different energy states, and when you have a lower energy state, the CO2, the energy has to go somewhere, and so it's transferred in an electric power plant to water, and it boils water, and the steam that is produced will be used to make electricity. What else should we say? Okay, temperature. Okay, so temperature is a measure of the amount of kinetic energy that is present in atoms. And what did we say last time when we were talking about CO2 in the atmosphere when it was acted on by solar radiation, infrared radiation? We had said what happens is it vibrates. It starts to vibrate more. Well, that's what all molecules do. They will vibrate more when you add heat to them. So temperature is the amount of this energy that is causing the molecules to vibrate. Now, when we talk about heat versus energy, there's a real subtle difference here. So if we have a small bottle of water that is at, we'll say 90 degrees Fahrenheit. I started to use centigrade, but so something that's like a warm bottle. And I don't know if you've ever gone to the swimming in like the Gulf of Mexico. Sometimes the Gulf of Mexico is like bath water. So when we talk about temperature, you can have a water bottle that has the same temperature as the Gulf of Mexico, sort of like lukewarm bath water. But there's more heat in the Gulf of Mexico because there is more molecules there. So they're vibrating at the same rate, that's the temperature, but there's more heat there because there's more molecules that are vibrating at that same rate. Okay. All right, so when we measure heat, or energy, when we measure energy, we have a couple of different types of units that we use to describe how much energy is stored or how much energy is present, well, let's say. And one of these is calories, and the other one is joules. Now, I'm a biologist, so the units that I'm used to dealing with are calories. And so when you were to look at a package, a Snickers bar that you might have bought at a convenience store, and you look at the back, it would have a certain number of calories on it, 200 calories, we'll say. And what an actual calorie is the amount of energy that's required to increase 1 cubic centimeter of water 1 degree centigrade. That's a very small amount of energy. Now, if you are a physicist, and I'm not a physicist, but if you are an engineer or a physicist, let me see, I've got to remember what a joule is. A joule is the amount of energy that is required to raise a 100-gram object, something like an apple, 1 meter against the force of gravity. Okay, so that one's a little harder for me to relate to, but it ends up that one joule equals 239 of these calories. So they are interchangeable, but it's a different form of a different way of describing the potential energy that is present, the amount of energy that's present. Okay.